All right, guys, let's take a look at number 4. Name the most chemically active halogen. Most chemically active. And a number of you asked me, well, what's that supposed to mean? Well, let's keep in mind, let's get in context. We're talking about the halogens, group 17. And if you're in group 17, how many valence electrons do you have? 7. So in terms of what you're trying to accomplish as a halogen, what is it? Get 8, right? So one more. Get one more. They're all trying to get one more electron. You're trying to get one more electron. And so the halogen that is trying to get one more electron the hardest, or the most, is the most chemically active halogen. Okay? You can surmise that from what you guys understand about halogens, in that they have 7 valence electrons. They're trying to get one more. But isn't there a trend that we've been studying that has to do with an atom's ability to attract an electron? Yeah, it's electronegativity. Electronegativity is the measure of an atom's ability to attract an electron. And so if we're asking which halogen is attracting an electron the most actively, we're essentially asking which halogen has the largest electronegativity. And so I'm going to use my group trend knowledge of electronegativity to answer this question. Electronegativity's group trend is that it increases as you go up the group. And so which halogen is at the top of the group? Fluorine. Fluorine. I'll write it out. Next up, right, it's electron configuration. You guys should be able to do this one, somewhat easily. 1s2, 2s2, 2p5. Now here's another one that you guys might, stumble at the question. Write the configuration of the most stable ion this element makes. Well, fluorine being a halogen wants to gain 1 electron, doesn't it? Because that's when it's going to have a noble gas electron configuration and be stable. And so the most stable form of fluorine is, right, fluorine -1. Or, that's most of you guys' grades in here, but we're going to have fluorine with 1 extra electron, 1 more electron. So we'll take this exact same electron configuration, 1s2, 2s2, 2p. Well, let's reflect the fact that we've gained 1 more electron just now, 2p6. Well, guess what? That's the electron configuration for the noble gas that's right next to fluorine, right? The noble gas configuration that fluorine was trying to get. We now have 2 plus 6 is 8 valence electrons. That's what we were trying to get in the first place. And that's how you can predict a halogen's behavior, based on the fact that it wants to gain 1 electron.